Hey, good morning, everyone. So, yesterday you guys completed the Wiser Sheet properties practice. I wanted to go over it just to make sure everyone had an understanding of what was going on. I saw that a few folks just weren't really understanding it, so hopefully this helps. So, the first problem was to complete the argument. Now, on this screen, you'll see that it's two columns. The first column is all the statements. The second column, which is hidden, is all the reasons for the statements. And you'll see that the problem says, given that 5x plus 1 equals 21, prove that x equals 4 by giving a reason for each step. So at the top of the column, you should always put down the given. It's given to you that 5x plus 1 equals 21. So the first statement that you put down is going to be the given. And the reason you put that down is because it's a given. So if you click on the yellow, you can see these are the three options. And the first one was a given, so you click on given. The second statement, we went from 5x plus 1 equals 21 to 5x equals 20. Well, what's the difference between the two? What did we end up doing? Well, when you get ready to solve 5x plus 1 equals 21, what you have to do is subtract 1 from both sides. If you subtract 1 from 5x plus 1, you're left with 5x. If you subtract 1 from 21, you're left with 20. So, since we subtracted from both sides, the reason that we got 5x equals 20 is because we used the subtraction property of equality. Now, why is it called the property of equality? Well, because we subtracted from both sides of the equal sign. So that way it remained balanced. The equation remained balanced because we ended up doing an operation on both sides of the equal sign. And finally, from 5x equals 20, the next statement is x equals 4. How did we get x equals 4? We divided by 5 on both sides. So because we're dividing by 5 on both sides, our reason is we use the division property of equality. And that's how we proved x equals 4 when we were given 5x plus 1 equals 21. So for the next one, it's very similar. It says, given that 0.5x minus 5 equals 10, prove that x equals 30 by giving a reason for each step. And the first statement that we put down is going to be what we were given, 0.5x minus 5 equals 10. And the reason we're putting it down is because it's already been given to us. Like we're told that's what we're starting with. The second statement that we're putting down is we're taking a 2 and multiplying both sides. So here we have 1 half x, 0.5 is 1 half, so 1 half x minus 5, and we multiply that by 2 in the second statement. We have 10, and we multiply that by 2 to get 20 in the second statement. So if we're multiplying both sides by the same number, that's the multiplication property of equality, because we're multiplying. Now after we have a 2 in front of the parentheses, we know we're going to have to distribute the 2, right? Whenever you see parentheses with a number outside of it, you should always think of the distributive property. So 2 times 0.5 x will just give us 1x. 2 times minus 5 will give us minus 10. On the other side, we don't have to distribute anything. There are no parentheses on the other side. So this way, we're only distributing on one side. Now, if we didn't do a distribution on both sides, can we say that it's a distributive property of equality? No, it would just be the distributive property, right? There's no of equality attached to the distributive property. Make sure you understand that because the parentheses are only on one side. They're not on both sides, so we can't say it's the property of equality. It's just the distributive property. Finally, we get x equals 30, which is what we wanted to prove. Now, how did we go from x minus 10 equals 20 down to x equals 30? Well, we added 10 to both sides. X minus 10 plus 10 will just give us X. 20 plus 10 will give us 30. So, since we're adding 10 to both sides, that's the addition property of equality. So you kind of should be getting the hang of this, right? The first, you always start with the given. In the end, you always put down what you want to prove, and then you do step by step, trying to figure out what happened in each step. And whatever happens in each step, you put down that the reason, right? So here we multiplied by 2 on both sides. Here we distributed the 2 in only the left side. So that's a distributive property. And then from going from here all the way to x equals 30, all we did was add 10 to both sides. That's the addition property of equality. So this is very much like solving an equation, right? In an equation, how you would solve this is doing exactly these steps. Here, all we're doing is adding in the reason we're doing all of those steps. Okay, the final question, actually no, not the final question. The next question was, prove that x equals negative 3.8 given 5 times x plus 3 equals 4. Justify each step by giving a reason. So again, we're given 5 times x plus 3 equals 4. We put that at the top of our statement list. And then the reason we can pick that is because it was given. Now, the next step, since we do have parentheses, we can distribute the 5. And that's exactly what we do. 5 times x is 5x. 5 times plus 3 is plus 15. Remember that the 5 has to be multiplied to each term inside the parentheses. So we get 5x plus 15. On the other side, there's no parentheses, so we don't do anything to that side. And the reason we did that was the distributive property again. Now you have 5x plus 15 equals negative 4. The next step is to get rid of the positive 15 next to 5x. And the way you get rid of positive 15 is you're going to have to subtract 15. And if you do it to one side, you're going to have to subtract 15 from the other side as well. So 5x plus 15 minus 15 gives us 5x. Negative 4 minus 15 gives us negative 19. Since we subtracted on both sides, that's the subtraction property of equality. Now, to get x by itself, we have to divide by 5 on both sides. So 5x divided by 5 is x. Negative 19 divided by 5 is negative 19 over 5. And that, because we divided by 5 on both sides, is the division property of equality. Finally, there's only one property left, but you should also know that x equals negative 19 over 5 and x equals negative 3.8 are exactly the same thing. Negative 19 over 5 is negative 3.8. Because they're the same exact thing, this is basically a reflexive property. It's an identity, right? It's something that is equal to itself. That's where the reflexive property comes in. Okay. Now, I wanted you guys to match the statements with the reasons in this section. So if you have 2x plus 1 equals 7, and then you have 2x equals 6, what happened? Well, you subtracted 1 from both sides, right? If you're subtracting 1 from both sides, which property is it? Well, it has to be a property of equality. So that narrows your search, and since you're subtracting, it has to be the subtraction property. So you can connect those two. The second one said, if 5x equals 20, then x equals 4. Well, how do you know? All you have to do was divide by 5 on both sides in this equation, right? 5x divided by 5 is x. 20 divided by 5 is 4. Once you do that, you know it's a division property of equality. You divide it by 5 on both sides of the equal sign. So it's equality and it's division. If AB minus BC equals 12, then AB equals 12 plus BC. This was a little bit tricky. What we did here, we added BC to both sides, and I'm not sure if everyone saw that. So AB, let's say it was a line segment AB, and we're subtracting another line segment BC to get 12. If we add BC to both sides, we're going to have AB minus BC plus BC, and the minus BC and plus BC will cancel out, so we'll just be left with AB. On the other side, if we add BC, we'll have 12 plus BC. So because we're adding BC to both sides, this is an addition property of equality. In the next one, we have AB equals AB. Well, we've already discussed this, right? Whenever we have something equal to itself, sort of like an identity or a mirror, right? Then that is called the reflexive property. Finally, we had if AB equals BC, then BC equals AB. We just flipped around AB and BC, right? Let's say 1 equals 0.5 plus 0.5. We can rewrite that as 0.5 plus 0.5 equals 1, right? 1 equals a half plus a half. If we flip it around, a half plus a half equals 1. It's exactly the same thing. And that's called a symmetric property. Symmetry means kind of like a mirror effect, right? You mirror them, you flip them around so that they're equal. And finally, we finished up with a little bit of a blast from the past, right? We talked about segment addition postulate before. Remember that it was when we have two segments, we can add them together to create a bigger segment. So, if we're given this picture, and in this picture we can see that xy, well, actually we're not given what xy equals, but in our reasoning statements, the statement is given that xy equals 42. That's a given. And we also see in the picture that xz, so this first segment, plus zy, the second segment, is equal to xy, and that's a segment addition postulate. That's also been given to us. Now, what did we do to go from xz plus zy equals xy to get to 3 times n plus 4 plus 3n equals 42? How did we go from here to here? Well, one of the things that we did is we simply replaced, right? We replaced xz because we knew how long it was. It was 3 times n plus 4. And we also replaced zy because we knew it was 3n. And we replaced xy because it was given to us as 42. So here we've basically done 3 different replacements. And to figure out what a replacement is, it's basically a substitution. Another word for replacement is to substitute, right? To plug in. You might have heard that before. So this was the substitution property. Once you use the substitution property, now it becomes a little bit easier for us. We know that we have to get rid of the parentheses, so what we do is we distribute the 3 across the parentheses. How do we do that? We multiply each term inside the parentheses by 3. So n times 3 is 3n. 4 times 3 is 12. We bring down the plus 3n and the equals 42 because there's no parentheses there. So that's basically the distributive property. Finally, we combine some like terms. So 3n plus 3n equals 6n. We can't add the 12 to it because it doesn't have a variable attached, right? There's no n. And we can't do anything with the 42 because there's also no variable attached. So we get 6n plus 12 equals 42 because we combined like terms. Finally, to get 6n by itself, we have to subtract 12 from this side. If we subtract 12 from this side, we also have to subtract 12 from the other side. That means when we subtract 12 from both sides, we'll get 6n on one side and 42 minus 12, which is 30 on the other side. And that is the subtraction property of equality because we did it on both sides. We subtracted on both sides of the equal sign. Finally, we want to get rid of this 6, right? Now we can't just subtract 6 because this 6 is being multiplied to the n. So the opposite of of the multiplication operation is division, right? So instead of subtracting 6, we would have to divide by 6. So 6n divided by 6 gives us 1n, which we can just write as n. Because we divided by 6 on one side, we have to divide by 6 on the other side as well. 30 divided by 6 is 5. So we get n equals 5. Again, that was using the division property of equality. So hopefully you guys were able to figure most of this out. If you didn't, please do use this video as a handy tool to help you with your upcoming assignments. If you have questions, please do reach out to me or drop a comment in Google Classroom just so your classmates can help you. I hope this helps.